Okay, 19 is neither. And let's take a look at y. One of your equations was y equals 7x. The other was y minus 28 equals 7 times x minus 4. But if we simplify this, do you see that this in point slope form actually simplifies to the exact same equation? They're not parallel lines. They're the exact same line. These aren't parallel. We would call those coinciding lines. It's the exact same line. Parallel lines is when we have the same slope but different y-intercepts. It was a little tricky. I'll give you tricky. Okay. Now, number 58. As I walked around, I saw that some of you left 58 because you got to it and you saw some variables and you thought, wow, this is harder than what I can do. Wrong. You must attempt that. You may not say, wow, this is harder than what I think I can do. Because if we look at it, it's just asking us what the slope of these two lines are. Well, we can plug this into y2 minus y1 over x2 minus x1. And if we find the slope of this line, we get y2, a, minus y1, 0, over x2, a, minus x1, 0. We get a over a, which simplifies to 1. Now, when we find the slope of this line, we're going to do the same thing. 0 minus a over a minus 0 is negative a over a, which simplifies to 1. Is this a hard problem? No! Does this look like what you could see on your end-of-course test or your next benchmark? Probably. Yes. Okay? It is not hard. But sometimes when they throw in variables, we get scared before we even kind of think about it and decide, hey, that's not too bad. So, you must try them. All right, any other questions? All right, let's move on. Oops, that was just 51. Okay, this is the answers for page 519. Now, on the board, I ask you to, on the starred problems, I ask you to give both the exact and the approximate. So on number 16, you should have 10.44 written on your paper and square root of 109. Does the square root of 109 simplify? No, it does not. So we leave it just like that. All right, 22. You may have just read part of the problem and written down the midpoint. Did any of you, I'm not going to ask you to raise your hand, but you may have stopped at the midpoint. Okay, they said a car broke down halfway between Jefferson and Milltown, which would be at the point 0.5 comma negative 0.5. But then they said, how far would the truck have to drive to get there to help the car? Well, the truck was in Jefferson. So we're looking for the distance from Jefferson to that midpoint. And that distance is approximately 2.5 miles. Okay, 24. 24 had several parts. You were asked to find the perimeter of this triangle given the 3 vertices. This you probably will see on your test. That's not hard. So you do the distance formula for one of the sides, and you get approximately 6. But the exact answer, which I asked you to give, the exact answer was square root of 34. BC had a length of root 26, which is approximately 5. And then CA has a distance of square root of 40, which obviously we wouldn't leave it like that. We would simplify that to 2 roots of 10, because this is 4 times 10, and the square root of 4 is 2, so that's 2 roots of 10. So the exact answer for the perimeter would be, because we can't add these, you just list them. There are no like radicals. This is the exact answer, and then that's the approximate answer. Okay?
Right, you get that.
All right, 28. 28 is the distance formula. And I've noticed throughout the day that most people got to 58 miles and stopped. That's not what they asked. They didn't ask for the distance. They asked how long it would take you. So if this is the distance and we're traveling 75 miles per hour, and we want to convert that to minutes, this is a great problem. This is like an end-of-course test problem because it involves distance formula. It involves conversion between rates. It involves multiple things we've done. Great end of course test problem right here. So you had to take what you found here, divide it by the 75 miles an hour, and we know that there are 60 minutes in an hour, so that would tell us it would take 46 minutes to travel that distance. Now, this 75 miles per hour is not a car. You did read the problem. It's talking about a helicopter, right? So, they're not recommending you drive fast.
I can drive.
I drove on the highway.
I'm a good driver.
I drove my dad's car.
That was so boring.
Y'all, okay.
65.
Y'all are 15?
Yes.
I drove
Okay.
on the highway. Yeah.
I've never done that.
Okay.
I drove by Andrew's house once.
All right.
That's awesome.
I want to know that you can do the distance formula. That's what I want to know.
I can do it.
All right. So 29. You got, I should have had you do the exact, oh, I did, on 29. All right, the exact for square root of 52. Well, square root of 52 breaks down into 4 times 13, doesn't it? So the exact distance is 2 roots of 13. Obviously, you know, if I'm driving down the road and my husband asks me, how far is it? And I go, 2 roots of 13. That wouldn't mean much to him. So that's 7.2.
33 equals words.
All right, now, this has frustrated me today. So much to the point that I'm going to probably start giving pop quizzes on certain things. On your summer work, I gave you a list of formulas that I expected you to know walking through the door at 9th grade accelerated class. Circumference formula is one of them. Okay? Circumference is 2 pi r or pi d.
I thought it was pi r squared.
That is area.
That is area.
And that makes me want to kind of flinch.
Fires you.
Okay? And I've discovered that there are some very basic formulas that y'all don't know. And some of you do know. I hate it when people say everybody doesn't know. I'm certain that not everyone knows the area of a triangle formula, which upsets me.
One half base times height.
Thank you. Area of a trapezoid.
Yep.
Area of a trapezoid.
Oh.
Half the height times the sum of the bases.
That's what I was going to say. That's it. Yep.
Okay? So there are some things that I was hoping you would have come to me with that knowledge that I think somebody didn't make you memorize along the way. And I think those are like basic skills we should know kind of things. So we'll know them. All right. So 35 is B, 36 is H, and 37 is D. How'd you do on those?
Got him.
Got them? All right. Let's move on. Today, we are not learning a new concept. We are applying the concepts we know to things we've already learned. Okay. First thing we're going to do is complete the graphic organizer on quadrilaterals. What's a quadrilateral?
It's like a
four-sided figure? A polygon with 4 sides? Okay. So that's what a quadrilateral is. So any polygon with 4 sides would be considered a quadrilateral. And then we have special names for quadrilaterals that have special characteristics. And we're going to talk about those today. Real quick. Leave the door cracked so nobody has to get out. You're welcome. You're welcome. All right. Okay, if anybody talks to Simon or Matt, let them know that I put the worksheets on the website just for them. They'll appreciate it. They'll appreciate that. Showing them the love. All right, so this is a graphic organizer that describes a quadrilateral family. And you can go ahead and add the arrows onto yours. The yellow obviously doesn't copy. And since I you may shut that. Nobody else is out. Okay, so we're gonna divide the quadrilateral family by looking at two specific things. We're going to look at congruent sides. And everybody knows that the squiggly with the equals under it means congruent. And what does congruent mean? Same size and shape. And so if we're talking about congruent sides, they are sides that have the exact same distance, right? Congruent sides, and then parallel sides. So these are the two ways that we're going to divide that up. Remember, the little parallel lines mean parallel. All right, so a kite looks exactly like a kite. Isn't that great? But what is true about a kite is that consecutive sides, we have two pairs of congruent consecutive sides. Do you know that if I mark it with one tick mark, the two sides that I mark with one tick mark are congruent?
Yes.
And the two sides that I mark with two tick marks are congruent.
Yes.
So the blue, you can see on my overhead, the blue sides are congruent and the red sides are congruent. So if I were to give you a figure on the coordinate plane and it looked like a kite, how could we prove that it's a kite? We would have to prove it by showing two pair of consecutive, yes, you should write this, congruent sides. Now, what have we talked about in the past 3 days that would prove congruent sides? What can we use? Good. The distance formula.
You heard me too.
I did. It was, I was reading somebody's brain.
It's probably mine.
I was about to say, like,
Something really off top, like from math related, but really off topic from what we're. You saved me right there.
Thank you, thank you.
Thank
All right.
you. Thank you.
I did not know that in the UK they call a trapezoid a trapezium, but apparently that's another name for a trapezoid. And cool. All right. What makes a quadrilateral a trapezoid? Well, what makes a quadrilateral a trapezoid is one pair of parallel sides. Did you guys know that when we put arrows on the sides, that means parallel? So these have one set of arrows. So that means that these bases are parallel sides. So what makes it a trapezoid? One pair of parallel sides. Now, what have we learned recently that would prove parallel? Same slope.
what have the same slope?
So we would have to find the slope and show that those slopes for this side and this side were the same. Okay, so now we're in the parallel family. We have a special type of trapezoid. And it's a trapezoid that not only has, obviously it has one pair of parallel sides, but the legs to the trapezoid are congruent. So an isosceles trapezoid, we would have to show that it has one pair of parallel sides. Is somebody repeating everything I say?
That was Kyle.
And
yeah, dude, that was definitely me, Matt.
the legs are congruent. So the parallel sides, obviously, we go back to showing the slopes are the same. Slopes of the bases are the same. And then to show that the legs are congruent, we would use the distance formula to show congruent legs. Got it? All right. Parallelogram. The name says it all. Everything's parallel. Okay? So we have two pair of parallel sides. So opposite sides are parallel. And how would we show that?
The same slope.
Yep.
Boom.
Now, this is the parallelogram family. Everything in this little family, everything that's true about the parallelogram, and we'll go into depth later on. Do you see that it has it marked like this angle is congruent to this angle, and this angle is congruent to this angle? There are a lot of things that are true about the parallelogram. Opposite angles are congruent. Consecutive angles are supplementary. Opposite sides are congruent. There's lots of things that are true about the parallelogram. We're going to go back and study that a little later. But right now, we're going to stick with the things that we can apply just parallel, perpendicular, and distance formula to verify that a figure in the coordinate plane is a parallelogram. So all you have to show right now is this. But all these figures that come up under the parallelogram, what's true about the parallelogram is also true about each one of these. So a rhombus also has opposite sides parallel. But in addition to that, all the sides are congruent. So, how would we prove rhombus? We'd have to show opposite sides have same slope. And we'd have to show distance formula that showed that all sides have equal length. Okay, now the rectangle. Everything that was true about the parallelogram is true about the rectangle. Also, what was true about the isosceles trap is true about the rectangle. But with the rectangle, what we're looking at is, what you want to see is that opposite sides are parallel, because it is a parallelogram. It falls in the parallelogram family. And consecutive sides, those that intersect, consecutive sides, what are they?
Right angles.
Good. Consecutive sides form right angles, which means they are perpendicular. So we're sticking with slopes on this one. We're going to show that opposite sides have the same slope, and that consecutive sides those slopes are the opposite reciprocal. Okay, so the square is down here at the bottom, and everything points to the square. So everything that was true about any of these is also true about the square.
So the square is special.
Square is very special.
I wish I was a square.
All squares are rectangles.
The circle.
We could say they're a rhombus. We could say they're a kite. We see that this falls under every other category. Okay, so what do we have to look for a square? Specifically, we'll do opposite sides parallel, consecutive sides perpendicular, and all sides congruent. So we want to show that opposite sides have the same slope. Consecutive sides have slopes that are opposite reciprocals. And then we'll use the distance formula to show that all sides are congruent.
I
is just a polygon with 4 sides. There is nothing really special about it. If you can't classify a figure to fall under any of the other categories, you would just call it a quadrilateral. If it doesn't have parallel sides, or if it doesn't have congruent sides,
Yeah, I'm not cut out.
all right. Go ahead, and as soon as you, I ran off another worksheet because the directions on the back of yours were not correct. I accidentally gave the wrong one to our student aide to print. So here we go. We ready, Ryan? Ryan's ready. Let's go. Okay. Go ahead and graph the first one. Our directions say use the coordinates provided and sketch the figure to determine the quadrilateral you created. So let's sketch ABCD. A, B, C, D. Okay, sketched it. Let's connect the dots. To me too. What kind of trapezoid? Is it a special one?
Are there different types?
What's yours?
Oh, yeah.
It looks to me as if it is an isosceles trapezoid. Now let's make sure we spell this correctly.
Mine's probably not mine's not straight.
Okay. So it appears to be an isosceles trapezoid. So what do we need to do to prove that it is? So now let's read the rest of the directions. Use what you know about parallel lines, perpendicular lines, and the distance formula to show that the quadrilateral is in fact what it looks like. You must show work for slope and distance to receive credit. So what do we need to show to prove an isosceles trapezoid? We need to prove that the bases are parallel. So we want to show that AB is parallel to CD, right? Okay, so what is the slope of AB? All right, we could use the slope formula, or since we have a graph, we could count. Down 5 over 5. Down 5 over 5 is a slope of -1. Okay, you find the slope of CD, please. You get -3 over 3, which is -1. The slope of AB is the same as the slope of CD. Therefore, the bases are parallel. All right, so we proved trap. Now let's see if we can prove isosceles trap.
Ooh.
What do we need for the isosceles part?
Distance formula.
Distance formula. We need to show that this is congruent to this. So we're going to do the distance of BC, so I'm going to put these two together. And then we're going to go back and do the distance of AD, so I'm going to put these two together. All right, so let's do BC. Do you guys know when I write segment BC without the little segment bar over it, it means distance? When you leave off the little segment bar, that is talking about the distance. Okay, so let's do, we'll let this be x2. So we'll do 7 minus 5. Oops, I'm not starting with BC, am I? Okay. So 4 minus 0 squared plus 7 minus 5. 7 minus 5 squared. Well, this is 16, and this is 4, so BC is the square root of 20. Ooh, yay, I get to practice simplifying radicals. What does the square root of 20 simplify to? 2 roots of 5. Good. 2 roots of 5. All right. Okay, so now I found BC. You guys find AD. Did you get square root of 20?
Yes.
Which is 2 roots of 5? So, AD is congruent to BC. So now we've proved it. We have proven that AB is congruent to, not BC, AD to BC. There we go. AB is congruent to BC. So we showed congruent legs and we showed parallel bases. We proved it.
Check marks the spot.
Does. That's a scary looking smiley face. I'll make it go away. All right. Your turn. Oh, those of you that are watching this on video that did not pick up your worksheets, I'm going to post the worksheets to my website just for you. See you Monday.